1.3. Let P be a prime number. If P divides A square, then P divides A. What is the theorem states? If P be any prime number, if P divides A square, then P divides A, where A is a positive integer. Okay, for that proof, let us take A be any natural number, that is A, and we want to find prime factors for that. A is equal to P1, P2, P3 and so on. Okay, now we want to find A square. A square is equal to P1, P2, P3 so on, Pn into P1, P2, P3 so on, Pn, which is equal to P1 square into P2 square into P3 square so on, Pn square. Okay, now we are given that P divides A square. If P is any prime number and P divides A square, therefore from the fundamental theorem of arithmetic, it follows that P is one of the prime factor of A square. Okay, what they are saying, if P divides A square, therefore from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. Okay, now however, using the unique partners of fundamental theorem of arithmetic, we realize that the only prime factors of A square are P1, P2, P3. So P is one of the P1, P2 and so on, and P divides A. I think you find a little bit confused. So I take an example to understand this concept theorem better. Okay, now see what they are saying. Let us consider A be any natural number and the value of A is equal to 10. Okay, now in the first step, what you are doing, they are finding prime factors for the value 10. So prime factors for 10 are 2 into 5. Okay, now in the third step, what they are doing, they are doing A square, that is 10 square, which is equal to 100. And if you want to write this 100 in terms of prime factorization square, this implies A square is equal to 100, which is equal to 2 into 5 into 2 into 5. Why I am writing this in terms of prime factorization? So 100 is equal to 2 into 5 into 2 into 5. Okay, now up to this step we have done. Now what is the statement? If P divides A square, okay, what is A square? This is the A square value. Now they are saying if P divides A square, therefore from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. If this total term can be divided by P, that means the P also belongs to any one of the prime factor. That is, it says that the value of P either may be equal to 2 or the value of P either may be equal to 5. Then there is the only case in which the total A square divided by P. Okay. Now, however, using this unique partners of fundamental theorem of arithmetic, we realize that the only prime factors are A square are P1, P2, P3 and so on. Hence, P also divides A. See, this second statement, what they are saying, in the first statement, if A square is divided by P, then P is one of the element of these two factors, that is either P value must be 2 or P value must be 5. But in the second statement, what they are saying, even though it is A square value, it is built only by the multiplication of two A terms. Do you understand what I am trying to say? Even though it is A square value, it contains the product of A multiples. So if again for this also P is one of the prime factor that is involved in the prime factorization of A. Hence, if A square is divisible by P, then A also divisible by P. Why? Because the terms in both a square and a are same. A square is nothing but a is multiplied twice. So it clearly says that if a square is divided by p, then a also divides by p. Okay, thank you.